So this last slide describes a single but relatively convoluted intermediate level SQL problem involving working with dates. In the process of solving this problem, a number of date functions and tricks with working with dates will be demonstrated. We start by describing the problem, which in and of itself is not all that difficult. We simply want to find the number of employees hired per each month of each year during the time period between hiring the first and currently the last employee. We want to include the months in which no employees were hired as well, since this provides information just as valuable to us. We start by learning about the employee table, specifically the hire dates, using the two simple queries at the top of MySQL 7 underscore 06 underscore dates SQL file right here. Okay, we can see from the first query, when you copy paste and run it, is that the number of years or time span runs uninterrupted from 2010 to 2014, so 15 years in all. The second query will show that, or shows that, the first employee was hired on March 15, 2010, and currently last employee on October 13th, 2024. Next, we're going to learn about date add and day of year date functions that will be used in the second stage of the problem to rewind March 15th to 2010 to January 1st, 2010 by subtracting the number of days rather in the year uh, for in the year for March 15, 2010 to get to get back to the January 1st. The same will be done with October 13th to get January 1st, 2014. I'll be the first one to admit that this would not be the way that I would think of solving this problem. I would simply extract the years from both of these, 2010 and 2024, and then construct January 1st using concat string function and then str to date conversion function. And I will demonstrate this technique in another problem later on. Okay, so I'm going to switch to the code, okay, and demonstrate. Let's see, we got multiple files opened, so I gotta sort of figure out which one is which. Okay, so I'm gonna go next and demonstrate this rewinding business with date add. Okay, starting with min of the hire date. Okay, that admin hire date. I should probably copy that. Um, Comma interval. Okay, for the date add function, you'll specify what is the interval that you use. And typically a day, but it could be a month or a year. In this case, the number is going to be negative because we are subtracting day of year, open close parentheses, the same min higher date, and then it turns out we have to add one to make the math work exactly, and then specify that that is the number of days rather than months or years. And give it a name as min FST HD. Okay, and we're going to do the same for the last date using the max function, replacing the min with the max here, here, as well as in the name. Okay, save that and test it to see that it gives us what we're expecting, which is, I forgot a comma again here. Okay, forgot the comma, and then we get what we expect, which is January 1st of 2010 and January 1st of 2024. Okay, so next what we want to do is fast forward this January 1st, 24 to December 1st, 24. That way, that it's going to be our last month, the first of the last month of the last year in the current time span. Okay, so the way we're going to do that, we're first going to copy this query and make it a subquery in the next query. All right, I'm going to use highlight and try to sort of indent with the tab key here, and I'm going to have open parentheses at the beginning and the one at the end, and it turns out I am required to create an alias here. I'm going to call this min max HD. Okay, and then I'm going to use that alias here to select the min first date and name it the same exact thing. There's no reason to change that one. And then I'm going to use again date add function on the max FST HD, okay, and interval of 11 months would be added, and that's going to be now called max LST HD. Should be December 1st, 24. Let's see if it is. Yep. So we still have a simple one row, two columns record set, right? With these two dates, the first month of the first year, right, which is January 1st, 2010, and the last month of the last year, which is the December 1st, 2024. Next, what we want to do is create a pivot table with sufficient number of indices or positions so that this entire time span in terms of months is covered, which is 15 years times 12 months, 180, right? So PT 200 would be enough, but I have a code already here in the procedure called procedure called insert into PT 1000 that's going to create 1,000 rows. I'm just going to copy, paste that, run it. So this will create both an empty PT 1000 table and the code right. I guess I maybe have to refresh that right here. If I call it, it's going to insert all these rows into PT 1000. So there's plenty of them, plenty of indices. And just keeps running this task for some reason. So now what I need to do is now I grab this entire thing here. It becomes my subquery for the next query. Okay, I'm going to have to sort of count my parentheses here correctly again. Okay. Somehow these, no, all of these are lined up all that well. Somehow. Okay, so this is the inner query again. Alright, so I'm going to have to close the parentheses here. Okay, I'm going to call then the alias for this entire query, which now again still consists, where were we? Those two dates, January 1st, 2010 and December 1st, 2024. And now I'm going to call that month HD. Okay, and I find a cross product with PT 1000. Okay, and I'm going to start by selecting everything from that just to see if it works. Okay, without any where clause. I might run for a while, hopefully. Let's see. Right, so it's going to repeat these two dates 1,000 times. Okay, that's fine. Okay, just going to clear that. Now, instead of having all these three columns, all I really want is starting with January 1st, 2010. I'm going to add, month by month by month until I get to December 1st, 2024. So it's pretty simple, but as you can see here, it's quite laborious process. So the first thing I want to try to do is create a date add function. Start with this first column, month HD dot min FST HD. Okay, and then add interval PT 1000 dot position -1, and then month, okay, and call that MTHHD, just one column, okay. So what that's going to do, okay, what's that going to do? It's going to start with the first date here, okay, and it's going to leave it essentially alone, all right. It's going to add 0 months, right, because the position is 1 minus 1 is 0. Then to that date it's going to add 2 months, and then it's going to get February 1st 2010, and then it's going to add yet another month to get to the March 1st of 2010, and keep going while, okay, or where I should say, where this date here, right, is less than or equal to month AG, right, dot last, right, max LST HD, which is simply December 1st. So for each one we check whether we've hit this particular date, and since it's in each one of them, it should work out. Okay, so this should simply be, unless I missed a parenthesis or a comma, just simply be the list of all 180, right, 180 dates from January 1st 2010 all the way to December 1st 2024. Okay, now next, let me add some blank rows here so it comes into view. Next, what we want to do is use the string to date conversion function, concat, and then simple month and year extraction functions to demonstrate the rewinding of the date to the first of the month for a particular year. Okay, so we'll simply copy paste the code to demonstrate how this works. Okay, so you'll see that each higher date, right, starting, well, those are not sorted here in a particular fashion, is rewound to the first of the month for that particular year. That's it. And then we can link up to all these 180 dates provided in this list. Okay, so that's going to be done in the very last query at the bottom of the code, right? First, what we're going to do is we're going to grab this entire query here and copy it, make it as a subquery over here. Okay, I'm going to again use the tab to move it to the right. All right, let me put the open parenthesis here, close it at the bottom, and call this as. I sometimes use the as keyword, sometimes just type month HD list. Okay, again, it has to have an alias. And then what we're going to do is we're going to, and it's better looking if I put that over here and bring it out a little bit. Okay, that's going to be then left joined with employee table, which I'm going to alias as EMP for short. Okay, and then on month HD list dot mthhd, which is the only column, right? That's this column right here. Okay, is equal to, now let's just bring this guy into here, right? Equal to, so from here I'm going to copy just this piece over here, okay, with the parentheses, this piece over here, okay, and then tab it in, add in some more. Okay, so it links up with what we call the MTHG or HD column here, where every higher date is rewound to the first of the month of the year. Okay, and then we group by the first of the month of particular year, and the order by it as well. All right, and then select statement, of course, has to have the month um, itself, right? The first of the month itself, and then it has a count of EMP, right, from the table to which this is joined to, right? Employee table, simply hire date as nom hired. I believe that is it. We'll see. This is probably the most complex one we had thus far. What are the odds? Up, it worked. Okay. So, as you can sort of tell, right, the left join assures that these months, like this guy here, the first two, for example, then there's plenty of them, April, May, so forth of 2010, and there's a bunch of zeros here. So all the months that where no employees were hired are also included. So that's a left join piece. Okay. So as you can tell, the problem could have been a little bit simplified, but it's a multi-layered approach that ultimately results in the correct counts. So to perform a brief verification of this, what we need to do is we need to copy this, okay, include the headers, go to Excel, paste it, okay, then just going to do a little formatting here, okay. So how can we verify that? So we could basically just copy all the. I did this, so I don't really want to repeat it. Let me find the file where I did this. Okay, I think it was this guy here. No. Hmm. I thought that was it. We got these guys here. So let's just improvise. Okay. Pay special. Okay, so what do we got? We got a column 97 hire dates, right? And so maybe I should have just kept that, right? So it has the first of the month, right? Like here, so I can maybe figure out if the count if is going to work here, right? So the range is the higher date, so we're bound to the first of the month, and then see whether the match occurs. Okay, fixing the. Okay. Yep, yep. So let's see difference. If this is not that, then flag it. Otherwise, leave it alone. Sum zero. Yes, so everything matches. You can do a little data analysis on it to see which were the months with most hires and so forth and so on, but I'm going to just let it go and be content with the fact that it did evaluate correctly. Okay, back to the presentation and the last slide. All right, so in this presentation, which consisted of a number of videos, we reviewed the one-sided and full outer joins and showed their use on several basic problems, including the last one, the employee hire dates, when we used the left join to include all those months with no hires. Most of the lecture videos were devoted to discussion of nested queries or subqueries. We distinguish between the two types. Type 1, where the subquery does not use any table used in the main query and as such acts as a procedure that is called once and its results are used in the main program. The type 2 queries are more complex because the subquery uses the table from the main query and as such executes fully for every single row of the record set from the main query. This is similar to the nested loops in programming where the inner loop fully executes for every iteration of the outer one. We also showed how to use subqueries in the from clause in addition to the where and having, and presented a number of intermediate level SQL difference and division operation problems. Finally, we introduced a few of the more challenging intermediate level SQL problems involving strings, numbers, and dates. Some of the examples involved working with CSV lists, both assembling and disassembling them, calculating the median and moving average, and performing a variety of date calculations. All of these examples made use of nested queries, and we'll continue to practice those with our university example as well as order entry database in the next assignment.